we've added the next three chips in, which are the three center chips here. And those are the 7474 that's used to generate the wait state, so the machine will wait for the slow ROMs to catch up. The OR gate here, and the inverter, which is two places here. So let's go ahead and look at some signals versus a schematic and just see if things are working the way we think they should. So let's power the machine up. Right now we're sitting at addresses 0. We should, this is the address decoder we looked at before, so if we examine, we should see that come low, and that's correct. I want to look at these two clocks. There's two clocks coming off the bus, phase 0 and phase 1, that are the clocks that the 8080 generates. So I should see on the 7474 pin 3 clock activity, and I do, and on pin 11, 8, 9, 10, 11 activity, and I do. On pin 3 of the 7404, there should be a signal, and that's the P-Sync signal. I don't honestly know how that one should act. Yeah. So when I do an examine, it pulses. Pin 4 should be the knotted opposite of that, and it is. So ultimately what should be happening here is on the Q knot, or let's see if this will focus, on the Q knot output, pin 8 of the 7474, this should pull low, indicating the machine's not ready and waiting for the slow RAM to catch up. So let's see if this pin here pulses every time I do a memory read from this block. So that's pin 8 on the 7474, which happens to be up here in this corner. It's sitting high, and each time I examine memory, I don't know if you can see that or not, the pulse LED pulses, where it's generating a wait state that would allow the slow ROMs to catch up. So that's working as I would expect. That's really good. And finally, the last signal to look at is pin 3 here on the 7432. That should go low every time there's a memory read. So a memory read, an address to code come in here and say, hey, we want to read the RAM. So on the 7404 or 7432 pin 3, it should be sitting, looking at the wrong device, 74, no, it's the 7432. Pin 3 should be high. Why is that a low? We have a low and a low. Why are those both low? There's our first issue. Should that be low? What happens if we actually run the machine? That may just be a quirk of the bus. I'm not sure. Because it definitely toggles. Let's get out of the F8. Let's get the address space below where we expect it to be. And pin 3, okay, should now be high. And sorry, you can't see the logic probe here. Oh, that's the 04, 7432. That's hard to get to. Okay, that makes sense. That pin should now be high. And if we go back and try to read an address out of the address block, it should come low, and that's good. Okay, this makes sense. That's doing what it should be. That would only be the signal that's gating the data from the EPROM onto the bus. So I really think, in poking around here, we can say that it looks like the generator here to generate the wait states is working. We're actually seeing activity out here when we do reads. We're seeing the signal that gates the data onto the bus during a read working. Debating whether I have this long. So SMAN read goes high when there's a read. pin 1 on the 7404 look like? Maybe I've got my... No, it's a high, and when I do an examine, it should pulse low. And it's not. Why isn't it? It's not pulsing at all when I do a read. So, okay, this is potentially an issue. .74, that's the LSO4. Pin 2 was thus low. Something here should be generating this SM read of pin 47 off the bus, and I'm not seeing the signal. So we may actually have a design issue here. I'm surprised that that's high. I'm going to have to go back and look at the bus definition. Like I said, I would expect that to be actually doing something each time I do a read here, and it's not. So looks like a design issue. The other thing I'll mention here is we had 2 mistakes in the schematic. I had the wrong pin number here and here. While I was wrapping, that become obvious, and I've corrected the pin numbers to 1 and 4. So it's progress, but something isn't quite working the way I think it should be here. Okay, I did some reading and a bit more studying, and I'll show you what's going on here with that SM read. So let's reset the machine. And we're going to get on pin 3 here. So we can get it shot. Pin 3 here, which would take the data from the EPROMs and put it on the data bus on the machine. And we're sitting here idle. Now looking at that pin, it's currently high. If we go ahead and load an address, in this case FF00, that says, hey, we're going to be reading from the ROMs, we stopped, it should go low. And my confusion here was it just seemed to be low. The SM read signal down here, which is right here, just seemed to be high all the time, which said it was reading. Well, the machine really is in a read state. If we go ahead and boot the machine, we'll see this behave like I expect it to. So we're on pin 3 here, where the ROM card would be saying, hey, I want to put data out on the bus. The low indicates, hey, I want to put data out. Let's reset. Examine address FF00, and I've got the floppy drives up and running because we're going to boot CPM. And what you'll see here when I boot CPM is a whole bunch of activity here. Then this signal will go high because we're done accessing the ROM card. And done. So during the time that the ROM card is needed, that signal becomes low on the board, which would gate the data off the board onto the bus. So this is acting exactly like I would expect it to act here now that I've actually seen it in action. My confusion was due to having the machine in the state it is right now, where it's just static, and it's static because it's reading, that memory address. So we'll do this one more time. Hit reset. We'll boot CPM. We'll see in here a bunch of activity, and then the signal will go high and stay high. So at this point, I'm convinced that all that part of the logic on the card is working. Really now the next steps are the 1897 buffers down here and getting one EPROM actually wired up so we can see if we can read from it. And that'll be coming up in a future video.